Good day, Jambite. Welcome to today's class. In today's class, I'll be diving into the world of heat and its measurement. Before you start watching, just pause the video and click on the subscribe button and make sure you like this video as well. Alright, so without further ado, let us dive in sharp. Our first outline, heat capacity and specific heat capacity. Now, what is the difference? The heat capacity of a body is the quantity of heat required to raise the temperature of that body by 1 Kelvin or 1 degree Celsius. While specific heat capacity, small c, of a body is the quantity of heat required to raise the temperature of a unit 1 kilogram mass of that body by 1 Kelvin or 1 degree Celsius. Now, looking at both definitions, you'll notice that both involves raising the temperature of a body, but the only difference there is a specific statement about mass. In heat capacity, mass is not involved, but in specific heat capacity, mass is involved. Now, if you look at the formulas I give, formulas displayed on your screen, you'll notice that in heat capacity, I denoted it to CH, the capital C and the small h beside as a subscript. Now, CH is equals to Q over theta. That Q is quantity of heat, and theta is the rise in temperature, or you can say change in temperature or increase in temperature. And your quantity of heat there is equals to the heat capacity times theta. That's your small, that's your CH. Now, for specific heat capacity, small c is equals to Q over m theta, and you can say Q is equals to mc theta. Now, if we look at the difference now, in heat capacity, you notice that in the formula there is no mass, but in specific heat capacity there is mass in the formula. The unit for heat capacity is joule per Kelvin, and the unit for specific heat capacity is joule per kilogram per Kelvin. Please put this on your head. Now, let us dive into the second outline. Understanding heat loss and heat gain concept. Specific heat capacity can be determined by mixture method and electrical method. Both methods are related to the relationships involving specific heat capacity. What this means is that both are applied based on the parameters given in the equation. Now, for example, now let me compare two substances together. Let me compare an electric let me say calorimeter. A calorimeter is an instrument used to measure heat. So let me just make use of an hot metal now for an example. An hot metal, that hot metal is my calorimeter. So I dip my hot water into a cool water now, into a cold water. You know, the metal I place inside the water will become cool, and when I dip my hand inside the cold water, the water will feel warm. So in this case, heat has been transferred from the calorimeter, which is the metal, to the water. So in this case, I can say that the heat lost by metal equals to the heat gained by water. So that's just the concept under the heat lost and heat gained. You have to know which one is losing it and which one is gaining it. In every question you are given, you have to know which one is losing it and which one is gaining it. This is very, very important. Now, by electrical method, quantity of heat is equals to I square RT. That's your Q, and your Q can also be equals to your PT. Your Q can also be equals to IVT, from V equals to IR. So these are the formulas under the electrical method. Now, you can say heat supplied by electrical device can be equals to heat gained by device, water, or anything that is gaining it. So when you're relating the heat supplied by electrical device and you're relating it to your specific heat capacity, so you can just say that your Q is equals to mc theta, PT equals to mc theta, IVT equals to mc theta, I square RT equals to mc theta. So these are the formulas under the electrical method. Now, look at these formulas well and add it up to your brain storage. Please be familiar with the formulas. Now, let us play with the following examples under the electrical method. Now, study these examples before I start solving them. Look at the examples, pen them down before I start solving them. Alright, so the first question says that an electric heater has a resistance of 50 ohms. So they give us our resistance as 50 ohms. When it is immersed in water and connected to mains source, it draws a current of 4.0 ampere. So they give us our current as 4.0 ampere current. Calculate the heat gained by the water if the heater is switched on for 2 minutes. RT is equals to 2 minutes. So is equals to 2 minutes, assuming no heat loses to the surrounding. So now this question is a very simple question, and since there is no heat loss to the surrounding, the heat gained by the water equals to the electrical energy in the heating coil converted to heat. So it's something that is very, very simple. You can just say your H is equals to I square RT according to the parameters we are given. I square RT according to the parameters we are given. First thing, we have to convert our minute, this time into seconds, so that will just be 2 times 60. That will give us 120. So we have 120 seconds. So H equals to I square RT. So let us just input our parameters. So we have I as 4, this is 4 square, and R as 50, and T as 120. So when we 4 square, that's 16. That will be 16 times 50 times 120. So when we multiply everything together, we have 96,000 joule. Yes, when we multiply everything, we have 96,000 joule. So that's the answer to the first question. Okay, now, so the second question says that a water of mass 1.5 kilogram M equals to 1.5 kilogram is heated from 30 degrees Celsius to 80 degrees Celsius. So let me just get my temperature change. That's my change in temperature. That will be theta 2 minus theta 1. So that will just be 80 minus 30. 80 minus 30. So I have that will be 50 degrees Celsius. So our increase in temperature is 50 degrees Celsius, and that's what I'm going to be using. So they said using electric kettle which is rated 5 ampere. So they gave us our current. As 5 ampere, and what else? 230 volts. It gave us our voltage, that's 230 volts. Okay, calculate the time taken to reach the final temperature, and give us specific capacity of water, which is a constant, C equals to 4,200 joule per kilogram per Kelvin. So these are the parameters we are given. Now if you look at the question, they say water of mass 1.5 kilogram is heated from 30 degrees Celsius to 80 degrees Celsius using an electric kettle. So they heat a particular amount of water using an electric kettle. So we can just say that our heat supplied by electric kettle is equals to heat gained by water. I won't be writing heat supply, just put it down in your book. Heat supplied by electric kettle is equals to heat gained by water, and that heat supplied by electric kettle with parameters given, that will be IVT equals to MC change in theta. So my I is from what they gave me, my I is 5. What they give us as V, our V is 230, and T, what's our T? Okay, they didn't give us T, so we are looking for T. Okay, T is unknown. So our M is 1.5, C is 4,200, and then change in theta is 50, So these are the things that we give. So with this, we can be able to find out T. So our T will be equals to 1.5 times 4,200 times 50 divided by 5 times 230 divided by 5 times 230. So when we multiply them and divide everything, first thing is, when you want to use your calculator, you first multiply the 5 times 230, that is the denominator, then you multiply everything up and divide it by the denominator. So after doing everything, we will get 237.9 seconds. 237.9 seconds. So this is the answer to the second question. In case you did not see this in your option, for example, this is a Jamb question and you did not see this thing in your option, you see it in minutes. You have to convert your answer to minutes. If you are converting this now to minutes, you have 4.57 minutes. 4.57 minutes. So this is the answer to the question. So now next class we will dive into mixture method and latent heat.